Last thing we're going to talk about is some properties of these systems that we've been working with this unit. Okay. All the answers that we've done when we've been asked to solve a system, either by graphing or by substitution or by elimination, there's only been one answer. That's not necessarily the case all the time. Okay. So I want to show you three different situations. So let's say that we were, and this is good review, asked to solve this system by graphing. So let's graph each one of these. You guys should be getting more and more comfortable with graphs now. What's that? Those are already graphed. Okay, well, I guess I'm graphing mine really quickly now. There, and there, on line, y equals x minus 1, there and there, draw a line. Okay, what's the solution to this system? Where do you find it? Where they cross each other. So what's the solution? Read this coordinate. What is that coordinate? -1, -2. Okay? One solution. Those are the ones we've been doing. Okay? Next one. This one's graph 32?
Yeah.
Okay. So I'll just do it quickly again. That's the same equation as last time, so -2 and -4. And then y equals -2x plus 3. 2, 1. What can you tell me about those two lines? They're parallel, okay? And what's the solution? There is none, because they don't cross. So exactly. So no solution. Because they're parallel. The last one. Let's graph these two. So we've already got them graphed. So if we do this one using intercepts, we get 1.5, which is not great, but that'll work. And 3. No, that's right. That shouldn't be right. Are those the same two equations that you have in your notes? Oh, yeah, because, wait a minute, that's not 1.5, 0.5. No, something's wrong. No, that's okay. That's okay. And then we do this one. So when I grab the red one, I got that. When I grab the purple one, it's right on top of it. How many solutions? Infinite. Because where do they cross? Everywhere. So this one would be infinite solutions. So how can we tell without having to graph. Okay? Because graphing is pretty time consuming. How can we tell if a system has just one, has none, or has infinite? What we do look at these two lines. What can you tell me about the slopes of these two lines? Are they the same? Are they perpendicular? Are they just different? Really? Really? What's the slope of this line? Go down 4 across 2. So that's -4/2, which is -2. This one is up 1 across 1, which is 1. Slopes are different. Whenever you have a system, if slopes are different, it will always be one solution. Always. Okay? What can you tell me about the slopes of these two? Yes, which means the slopes are, they're the same, right? They're equal to each other. But the y-intercepts are different, aren't they? So, if the slopes are equal, but y-intercepts are different, they're going to be parallel to each other. And they're never going to meet. Which means there's no solution. Okay? So if the slopes are the same, but they have different y-intercepts, no solution. How about the last pair for infinite? What could you tell me about their slopes and y-intercepts? They're the same for both. So if slopes and y-intercept are equal, that means infinite solutions. So that's how we can find how many solutions a system has just by looking at their equations without having to graph. Okay? So let's look at a couple of practice. Let's look at a couple of examples. Okay. Here we've got 3 systems. I am asked to find the number of solutions for each. I'm not asked to solve it. I'm just asked to find the number of solutions. Well, to do that, I need the slopes and the y-intercepts, right? What form can I put it in so I can read the slopes and y-intercepts right off the equation? Yeah, I got to take each one and put it into y equals mx plus b. So I've got to take x plus y equals -2 and get y by itself. What do I have to do? How do I get y by itself? Subtract x from both sides. So I get y equals, write the x term first, then the number. What's the y-intercept of this line? -2. What's the slope of this line? -1. Now I gotta put this one in slope-intercept form. I gotta get y by itself. This is gonna take a couple of steps. First, I gotta get rid of minus 2x. How do I get rid of minus 2x? Plus 2x. Plus 2x. And I get negative 2y equals 2x plus 4. But y is still not by itself. What do I have to do to get y by itself? Divide by negative 2. And I get y equals negative 1x, or just negative x, minus 2. So these are the two equations I want to look at. What's the y-intercept of this one?
2.
Careful.
Negative 2.
And the slope?
Negative 1.
Negative 1. What can you tell me about the y-intercepts and slopes of these two? Which means how many solutions?
Infinite.
If they're the same, it's the same line, which means infinite. And we got to do the same thing for B and C. So I'll do B, I'll just do B over here. So 4x plus 6y equals negative 10. I got to put that in slope-intercept form. What do I do first?
4x on both sides.
Minus 4x, minus 4x, and I get 6y equals negative 4x minus 10. Y is still not by itself. How do I get y by itself?
Divide 6.
And whatever you do to one, you have to do to everything else. What is negative 4 divide 6? Negative 2 over 3, right? If it doesn't divide cleanly, leave it as a fraction, but reduce it. So negative 4 divided 6 is negative 4/6, which reduces to negative 2/3, and then there's an x up. What's minus 10 divided 6? Negative 5 over 3. So there's my first equation. Second equation is negative 2x minus y equals negative 1. Got to get y by itself. Sorry. Thought I heard it.
3x on both sides.
Add 2x to both sides. And I get negative y equals positive 2x minus 1. We haven't solved for y yet because we've got a negative. What's the quick way to fix that? Yeah, change all the signs. Make this positive, which means this positive has to become negative, and this negative becomes positive. What happened here? Any solutions? Just one. Why? Because the slopes are different. These are different, which automatically means they're going to cross at some angle, which means they're only going to intersect once. So one solution. And finally, C, which I'll do down here. So 3x plus y equals -1. How do I get y by itself?
Minus 3x on both sides.
Got 3x from both sides. I get y equals -3x minus 1. That's the slope-intercept form. So I've got that one done. That was nice and quick. Second one is going to take a couple of steps. -6y minus 2y equals 12. Wait a minute. What did I say? -6x minus 2y equals 12. How do I get y by itself here?
Plus 6 on both sides.
Plus what?
6x.
Plus 6x, yes. And I get -2y is equal to 6x plus 12. One more step to get y by itself. Divide -2, divide -2, divide -2, and we get y equals -3x
Minus 6.
minus 6. Can you tell me about the slopes? Same, but the y-intercepts? Different, which means they're parallel, which means no solution. Excellent. Okay, last example. We're given one equation. We're asked to find the second equation in the system so that both have either one, no, or infinite solutions. What should I do with this first? Put it into slope-intercept form. And it's pretty straightforward. I just have to add 2x to both sides. So I get y equals 2x plus 4. Tell me an equation, tell me a second equation so that when paired with this one, there's one solution. One solution, what has to be different? The slopes. So just give me a different number besides 2. 6. You don't even have to change the y-intercept. You can if you want, but that's it. As long as the slopes are different. No solution. What do the slopes have to be? The same, but the y-intercepts have to be different. So I've got to write 2x to get the same slope, but I've got to write a different number besides 4. Sure, plus 2. Any number will work. -5. Whatever. Slopes, same. Y-intercepts, different. This last one's probably the easiest one. Yeah, doesn't everything have to be the same? So just write the same equation. The slopes and y-ins Same. Okay. So just remember, when you're trying to find how many solutions a system has, you've got to use algebra and you've got to use slope-intercept form to compare. Okay. Okay.